Hi guys, so today we're going to take a look at question 6 from the 2016 exam paper 2. Okay, so a local sports club is planning to run a weekly lotto. To win the jackpot of €1,000, contestants must match one letter chosen from the 26 letters in the alphabet and two numbers chosen in the correct order from 0 to 9. In this lotto, repetition of numbers is allowed. So M33 is a possible outcome, for example. Calculate the probability that M33 would be the winning outcome in a particular week. Okay, so let's just try and outline how this works. Okay, so um, one letter and two numbers. And the numbers have to be in the right order. Okay, so let's look at for M33. So, well, what has to happen for M33 to be the winning outcome? Well, M has to be drawn. And then a 3 has to be drawn. And then another 3 has to be drawn. So we can sort of split it up into these three events. So this whole event, M33, is three events put together. M being drawn, a 3 being drawn, and another 3 being drawn. So if we want to look at the probability that M33 happens, so the probability that all three happen, well, that will just be the probability that M happens times the probability that 3 happens by the probability that 3 happens. Because, as you would expect, an A being drawn would not affect the chances of what number is drawn. And, the first number being drawn doesn't affect the odds of the second number being drawn because, as they outlined, repetition of numbers is allowed. Okay, so the probability that an M is drawn, well, we can just assume that that's 1/26th, since there are 26 options and only one of them will work. The probability of a 3 is drawn in the same way is 1/10, because there are 10 options, 0 to 9, and only one of them will work. And then again, the probability that a 3 is drawn is 1/10, which is 1/10 because there's 10 options. And so the probability that all three of these happen is just the product of the individual probabilities. In other words, these events are independent. And so then this is 1/2600. So the probability that M33 is the winning outcome in a particular week is 1/2600. Now, on to part 2. So if a contestant matches the letter only, or the letter and one number, but not both numbers, they will win €50. Using the table below, or otherwise, find out how much the club should expect to make or lose on each play, correct to the nearest cent, if they charge €2 per play. Alright, okay, so we have two parts to this question. So, part 1 would be to fill in the table. And part 2 is to calculate the expected profit or loss for the club on each play. So calculate the expected profit or loss for club on each play. So we're not even going to think about part 2 for now. So we'll just focus on part 1 and fill in a table. Okay, so in the first column is the payout of each outcome. Okay, well, we know that if they win the jackpot, they get €1,000. If they match a letter and one number, but not both, they get 50, so that's here and here. If they only match the letter, then they also get 50, so that's here. And if they fail to win, well, they get nothing. Okay, so that's the first column figured out. And now we want to find the probability of each of these things happening. Well, we already know the probability that they win the jackpot. Well, we know the probability that any one thing wins the jackpot. You have to get a letter right, which has probability 1/26. Then you have to get the second number right, which has the probability 1/10. And then you have to get the third number right, which has probability 1/10. And then probability that you get all of them right is just the product of those. So it's just 1/2600. And if you think about it, each outcome should be equally likely. Okay, so now what's the probability that we match a letter and the first number only? So first of all, we might notice intuitively these two should be the same. The probability that you get the letter and the first number, but not the second, should be the same as the probability that you get the letter and the second number, but not the first. Because the probability that you get the first number is the same that you get this probability that you get the second number. So we'll just calculate one, and then we'll be able to put in that same value for both. Okay, so what is the probability of match the first letter, the letter and the first number, but not second? Okay, well, like we did in the first question, let's write out what has to happen for this event to take place. Well, first you have to match the letter. Then you have to match the number, the first number. So let's call that number 1. And then you have to not match the second number. Let's call that number 2. Okay, and now let's break down the probability of each of these individual events. So the probability that you match the letter is again 1/26. The probability that you match the first number is probability 1/10. And the probability that you don't match the second number, well, if the probability that you do is 1/10, then the probability that you don't is 9/10. Okay, and then if we multiply these, so for all three of these to happen, the probability is the product, and we get 9/2600. And then we also get 9/2600 here. And the reason why is, well, we sort of explained it, but just to show it, it would be your probability you match the letter times the probability that you don't match the number times the probability that you match the number. So the 1/10 and the 9/10 have just swapped, but it's the same product. Okay, and now what's the probability that you match the letter and neither number? Okay, well, what is it we're looking for? The probability that match letter but not the numbers. Okay. Well, again, what has to happen? Well, we have to match the letter. Then we have to not match the first number. And then we have to not match the second number. I'm just going to call this N2 because I'm running out of space. Okay, so again, 1 over 26, probably starting to feel repetitive because it is. Not match the second number, probability 9/10. Not match the first number, probability 9/10. Not match the second number, probability 9/10. And again, we multiply these because these are the three events we need to happen. And we get 81 over 2600. 81 over 2600. And now for the final probability, the probability that you don't win, well, that's just 1 minus the sum of the probabilities, the sum of these probabilities. Because all of these are the ways to win, and so everything else you won't win. So not winning is just 1 minus this. Okay, so if we add these up and take it away from 1, so we'll get 1 minus 1 over 2600. Actually, it's the same denominator, so we can just do it like this. 1 over 2600 plus 9 over 2600 plus 9 over 2600 plus 81 over 2600. And that is just, well, this whole thing adds up to just 100 over 2600, or 1 over 26. So 1 minus this just equals 25 over 26. So this has probability 25 over 26. Oops. Okay, and so now the third column is x times px. Well, that's the payout times the probability of that payout. So sort of like the expected value. So for the first row, x times px is 1000 times 1 over 2600, which is just 5 over 13. For the second and third row, it's 50 times 9 over 2600, which is 9 over 52 for both of these. For the fourth row, it's 50 times 81 over 2600, so we just get 81 over 52. And for the last row, it's just 0, because we've got 0 times 25 over 26, just 0. Okay, and so we filled in the table. That is the first part of the question done. Okay, now we're going to move on to the second part, and we want to calculate the expected profit or loss for the club on each play. Okay, well, let's just think about this. So we're calculating the expected value. The expected value of each play for the club. Okay. Well, what is expected value? Well, expected value is the sum of the value of outcomes times the probability of that outcome. So the value of an outcome, let's call that x1, times the probability that that outcome occurs, and then the sum of this over all the outcomes. So the value of the second outcome times the probability of that outcome plus the value of the third outcome times the probability of the third outcome, so on and so forth. And let's say there's n outcomes, so the value of the nth outcome times the probability of that outcome. So this is how you calculate expected value. So we're going to use this formula for our situation. And so the payout is, okay, so straight away they're getting €2 from each play. So they're getting €2, okay. Let's call this expected value of big X. Let's just say that's the value of each play for the club. Well, they get €2 guaranteed, okay? And then they lose 1,000 with probability 1/26, so that's the X times PX. So that's they've actually very usefully, they've already gotten us to fill out this column, which are the X. That's the X times PX's. So we could just sub in these values that we've calculated. So 2 minus 5/13 minus, so they lose, that's the expected loss of a jackpot, minus 9/52 minus 9/52 minus 81/52 minus 0. So this is the expected value of a play for each, for the club. Expected value of each play for the club. Because they definitely get €2 from the entry fee, and then they pay out, you know, a jackpot with a certain probability. They pay out 50 with a certain probability. And so if we add all of these up, we get minus 15/52, which is minus 0.29 euro. Okay, so they should expect to lose, so let's just write that out. They should expect to lose 29 cents on each play. So that's a pretty poorly set up system. You know, they expect to lose, so they should be charging more than €2. And if you could calculate this, if you found something like this in your local community, well, you probably don't take advantage of it if it's your local community. But if you did, you could theoretically play as many games as you wanted, and eventually you would make money because you would expect to win 29 cents on each play. Okay, the club then estimates that the average number of players per week will be 845. If the club wants to make an average profit of €600 per week from the lotto, how much should the club charge per play? Correct to the nearest cent. Okay, so they figured out maybe we probably shouldn't be charging €2 because we're going to lose money. But they want to make 600 per week. They want to make 600. And there's going to be an average of 845 players. So they want to make an average of 600 over 845 euro per player. So on average, they want to take whatever this is, 600 over 845 is 71 cents. They want to make 71 cents per player on average. Okay, so we calculated the expected value of each play for the club if they charged €2, and it was minus 29 cent. Okay, and so we have our formula. The expected value, let's call it E of x, is the amount they charge, which was €2. Let's call this P, the price of a ticket, minus the probability of each payout times the size of that payout. So we had these terms minus 5 over 13, minus 9 over 52, minus 9 over 52, minus 81 over 52. And they want this expected value to be 71 cent because they want to make, on average, 71 cent per player. Okay? And so now we just have a very simple equation. So 71 cent would be 0.71 euro, and that's what we're working with. So then if we bring over all these numbers to the other side of the equation, then we should be left with P equals 0.71 plus all these fractions, which is, so 0.71 plus 5 over 13 plus 9 over 52 plus 9 over 52 plus 81 over 52, and this equals €3. So they need to charge €3 on the button if they want to make an average of €600 per week.